everyone, welcome to the new video. So this video is a continuation of our previous video for of IP address, where today we'll see more about IPv4 and IPv6. So without further ado, let's go.
So if we see IPv4 and IPv6, first of all, IPv4 full form is Internet Protocol version 4 and IPv6 full form is Internet Protocol version 6. So first IPv4 came because when it was started, we didn't knew that we will have so many devices connected over a network and we will use Internet Protocol. So that time like if we see there are the possibilities that time was more than a billion, which we thought will be enough. But now as we're exhausting IPv4 addresses, that's why IPv6 came into picture and new type of internet protocol addressing method came with IPv6 because we need more addresses now. So and that's why IPv6 came and IPv4 uh, was used earlier. Like it is used, but as we are nearly exhausting it, that's why we have introduced IPv6 too. So with IPv4, IPv6, we are addressing, creating a unique identifier to any device which is connected over a network and it is using internet protocol. Okay, why this is needed? As explained in previous video, it is needed so that if we want to communicate with that device or send data, we have a unique identifier which we can use to connect to that device. So, what is the difference between IPv4 and IPv6? See, IPv4, as you can see, there are four numbers which are separated by dots 198.168.0.1. So, there are four numbers which are separated with dots. Okay, that's why it is IPv4. Okay, version 4 basically. Now, in IPv6, we are seeing that there are eight numbers, like we can see eight blocks or eight numbers 1, 2, 3, 4, 5, 6, 7, 8, separated by a block, or you can say colon. And these numbers are not just simple numbers, they're hexadecimal numbers. As you can see, it's a combination of letters, the alphabets, and the numbers. Okay, so this is a difference and this combination was decided so that we don't exhaust IPv6 also that early. That's why this combination is decided. Okay. Now IPv4 is 32 bits and IPv6 is 128 bits. Why? How? I'll explain you. In IPv4, these numbers 198, 168, these are bits. 8 bit. It represents 8 bits. Why 8 bits? Because these numbers can be between 0 to 225. Because 2 to the power, if I do 8, it give me 256. So how is the numbers, which are separated by dots, how we decide that what numbers should come here at this place? We see that this number should be between the range of 0 to 255. Okay, we have to keep it in, it is representing bits. Okay, so this number, every number should be between 0 to 255. And that's why, because we have four numbers like this, so 4 into 8, that's why 32 bits. Okay, got my point? These number you will always see in IPv4 addressing, the numbers are always in the range of 0 to 255 because each number represents 8 bits. Okay, and because there are four 8 bits number, that's why 4 into it, total 32 bits. Got my point? Now in IPv6, if we see, there are 128 bits total. How? So if you see there are eight blocks, okay? 1, 2, 3, 4, 5, 6, 7, 8, right? And here, if we see that each block has okay, four numbers, 1, 2, 3, 4, and these numbers are hexadecimal numbers. These numbers are not like these numbers, 8 bits, these are hexadecimal numbers. That's why the each block is representing 4 bits. Okay, each block is representing 4 bits. So if I say in one block we have 16 bits, and similarly 16 bits, so 16 into 8, 1 2 3 4 5 6 7 8. So 16 into 8 will be equal to 128 bits. Okay, either you do this way that one block is 4, and because there are 4 in one block, so 4 into 4, and then total we have 8, that's why 128. Okay, so this is the difference between IPv4 and IPv6, and why IPv6 has came into picture even though we had IPv4. Now we'll understand how in IPv4, when how this addressing works. Okay, we'll understand in IPv4. So there are two types of assignment with how IP addresses get assigned, like IPv4. First is manual assignment, that administrator will assign your IP address, your subnet mask, your gateway address, your DNS manually. What is all this like subnet mask, gateway? We'll understand more later on. Then automatic assignment is we request DHCP. So this is we request our device request to DHCP that we need an IP, and whatever is available IP, that IP gets assigned. Okay. Then we have public IP and we have private IP. So public IP is generally provided, by internet service provider. Private IP is like the private organization, and those mostly start with like 10 dot something or 198 dot or 172 dot. Okay. So in this way, there the assignment is done, and now we'll talk about the subnetting part, okay, where we are dividing the network into smaller network. Like we have taken the many IPs, and now we are dividing or organizing or giving them into smaller networks. So how that works? Now, subnetting is dividing any network into smaller network, or dividing a network into into devices. So when basically in subnetting we use like this 192.168.1.0/24. So what does this mean? It means that there is a network address, there is then a address assigned to devices which belongs to this network, and this address is basically to receive the data. Okay, so basically what this part is representing, that this part is the network, and this network range belongs to all the devices. So basically it is an identification of a network. It does not represent, it represent whole network, that this is a network, and any device which comes under this network, or it is inside the range of this network, is the part of this network or subnet. Okay, so this is a network address, that's why it is called network address. It's a identification address. Okay, the IP addresses which can be given in a subnet of this network address usable is 192.168.1.1 from here till 254, because last address and first address is reserved for network address and broadcast address. Similarly, we have like 16. And so I forgot to add this. Subnet mask will be like 255.255.255.0. We are masking the network, okay, but this mask is like 250, the bits that can we can give, so 255.2, but this can be anything, it can differ. That's why it has been assigned as 0. So this is like masking the network address. Okay, so if we replace, okay, 24 by 16, so it means that the 16 bits of the of this address is the network address. Others are the usable host range which can be assigned to devices. Okay, so if we see that each bit is of 8. Okay, so 16 bits means 192 subnet mask will be, now this will be 16, 8 and 8, 16, and these remaining will be, now we can assign, we can use it. So similarly here also, it means that we can, okay, so 16 bits will be fixed and others will not be. So this will be the network address. Okay, this will be the broadcast address, and the usable host range will be from 0.1 till 254, sorry, 255. And so basically first is reserved for the network, which represent network address, and this is broadcast address. Similarly, if I say 8 bits, so here again it means now only this is fixed and the rest all are can be assigned. So this is the as soon as more the fixed part is removed and dynamic part comes into picture, we have more number of addresses that we can use, or you can usable host range. So I hope this clears your confusion between the how the IP addresses works, and how what actually is what actually works behind this IP addresses bits. So that's all.
So that's it for today's video. I hope it's helpful. Please let me know your views in the comment section. Till then, take care. Bye.